Hey everyone. Oh, everyone hear me in the back? Good? Thumbs up. Awesome. Sounds great. Well, we're here to give a very exciting presentation. This is ANT331, AWS Analytics Enabling Fraud Prevention for Sony's PlayStation. If this is what you were expecting, congratulations, you're in the right room. If not, well, stay a while. We've got some exciting stuff to share. We've got some amazing presenters up here, but you'll see that yourselves. This is really exciting for me personally. I've been a lifelong gamer. In fact, PlayStation was my first console back in the 90s. This is actually my original Sony PlayStation 1 controller. Dug it out of my closet and brought it here. I'm really excited to share some of the exciting things that Sony is doing to power the current and next-gen PlayStation functionality for customers and gamers and users. But without further ado, let's get into it. So let's talk a little bit about the folks that are up here today in front of you. Eric, you want to start it off?
Sure. Thanks, Nick. Thanks, everybody, for attending our session today. My name is Eric Krause. I'm an engineering manager responsible for the fraud team in PlayStation's commerce platform. I have about 25 years experience in the industry, mostly focused on financial services and e-commerce. Been with Sony for about 11 months. And I love the dress code change, if you couldn't tell. Here you go, you can have that back. So I have a background in software engineering, full stack Java and .NET engineer. I've been an active speaker for the last 3 years. I love doing it. I usually talk about Agile or DevOps or API management. And a personal note, been married for 12 years, and I have 2 wonderful little boys. Pass it over to Tom.
Hi, everyone. Tom Lilly. I'm a staff software engineer in the commerce department at Sony Interactive Entertainment. My role is the technical lead for the fraud and risk team. So we're building the back-end services on the PlayStation network, excuse me, that analyze fraud and risk as customers interact with our store. I have over 10 years of software development experience, 3 of which is with SIE. And I'm actually fairly new to AWS. I was in your seat 2 years ago in my first reInvent in 2017. Now I'm up here sharing our story, so really cool, really excited to be here.
Awesome, and then there's me. My name's Nick Walsh, and I am a technical evangelist at Amazon Web Services. Essentially, my job is really amazing. I get to be a developer that works on developer tools and help developers like you leverage the awesome services that we're going to talk about today and how to build complex applications like the Eve platform that we'll get into in just a bit. I work primarily in AI and machine learning and anything that touches video games, but when it really boils down to it, I love working with anything that involves using data to solve novel problems. I have a bit of an unconventional background. I've done everything from building systems and writing software to help diagnose apathy and depression for clinical neurology patients to designing shark species identification systems to help curb illegal fin trafficking. Now I help you write code for the cloud. And even before I've worked at Amazon Web Services, I've actually been teaching it to developers on the collegiate hackathon scene circuit for many years. But this is actually my first reInvent in person, and I followed along closely as a customer in prior years. So very excited to be here. A little bit more about Sony.
Great. Thanks, Nick. So in case any of you guys haven't heard of us before, we're Sony Interactive Entertainment. We're a wholly owned subsidiary of Sony Corporation, and our main headquarters is in San Mateo, California. We're recognized as a global leader for entertainment, delivering digital goods for the PlayStation brand. Our first product, PlayStation 1, was delivered in 1994 in Japan, and we are responsible for the family of PlayStation products. So that includes PlayStation 4, PlayStation VR, PlayStation Store, and the PS Now. So whenever anybody talks to me, they say, man, you work for PlayStation, you must make video games. Well, we also do that as well. We're responsible and we oversee Worldwide Studios. Worldwide Studios is responsible for developing exclusive content for the PlayStation. And you might know some of our games such as Gran Turismo, God of War, or Horizon Zero Dawn that we're very, very proud of. So now that's been a little bit about us. Let's go into the agenda and what we're going to talk about today. We want to deliver a very exciting story today, talking about what my team does, the technology that we've been able to leverage on AWS, and what the results are, and maybe some lessons learned. So we're going to start with an overview of the initiative. Then we're going to go through an overview of technology. Nick's going to talk a little bit about the managed services that we use, and Tom's going to talk about how we actually incorporated them within our product. We're going to go through a review of the results. We're going to talk about lessons learned, because obviously nothing ever goes perfectly, and we'd love to share that with you. And then we'll go in with some Q&A. We should have about 10 minutes right at the end, but if you need to talk to us afterwards, we'll be across the hall. So an overview of the initiative. What does my team do for commerce engineering? Well, our job is to protect customers on the PlayStation Store. The vision is that we want to be able to enable a world-class system where customers can enjoy, play, and stay, and transact in commerce and feel safe about it. Our job is to protect the brand name as well as protect revenue against fraudulent and people that would try to exploit us. Our mission is to do this by employing a real-time data analytics tool that can proactively identify and stop bad actors in real time. So how did we do this? We created Eve, or Event Verification for Enterprise. And what this is actually a fraud risk decision for user-initiated transactions. And what it really is, it's an event interceptor. So at key points of your journey through PlayStation Network on the PlayStation Store, we identify certain transactions, and we provide real-time risk decisioning for it. So now you know what my team does, but what are some of the goals that we have for PlayStation Network? So first, we want to be able to provide a real-time 360-degree view of fraud and risk on the platform. Again, protecting your experience and letting you do the things that you want to do. The reason that we do it internally is we want to be able to have granular control of our destiny. We want to be able to turn the knobs when needed to be able to stop bad actors. This, in turn, would create a world-class customer experience that, again, is one of our main goals and objectives. Now, with centralized risk management, what we're able to do is have the ability to proactively deal with these bad actors at time when they're actually creating that nefarious deed. And lastly, why we're here to what we're talking about, it gives us the ability to plug and play with leading class technology, these AWS managed services. So we talked about some of the goals. Now let's talk a little bit about why we're doing it. We have a use case N, and use case N is kind of our guiding principle of how we're creating these event interceptors. The challenge that we gave ourselves was for the PlayStation Network to improve its ability to assess events in real time on the commerce platform to prevent fraudulent activity. The goal here was to create a multi-tenant system that our teams could consume as a SaaS model for different transactions across the PlayStation platform. Solution, it's Eve. Eve has been created to be a one-stop shop for fraudulent and risk management systems. So let's actually go into one of the real use cases, the first use case that we delivered on this platform. First use case is Eve purchase. And the purchase event is any time that you transact a purchase on the platform with the console, web, or mobile, and in-game purchases. The challenge that we gave ourselves was to further prevent fraudsters who would use stolen or fraudulent credit or user information to transact and purchase things on our platform. Now, the goal here was to be able to have the highest approval rate possible with the lowest chargeback rate possible. Because after all, we could just open it up and we could approve every transaction, but that's not really going to solve the problem. And in case you don't know what a chargeback is let's say that you looked at your credit card statement and you saw a charge and you say, you know, I didn't do that. You go back, you contact your bank or your credit facility and say, I dispute that charge. Then they'd come back and whatever the corporation that initiated that transaction, they'd try to get their money back. This is definitely not what we want, and it provides a horrible experience. So the solution was Eve Purchase. And Eve Purchase evaluates every purchase transaction on the network. And what we do is we provide decisioning for acceptance and denial, leveraging big data and advanced machine learning. Second use case was for login. We call this risk-based authentication. The challenge to us was to further prevent fraudsters who would use stolen account information and perform an account takeover, actually stealing your account and taking over possibly your payment instruments or your digital entitlements. The goal was to protect the network from users that wanted to commit malicious intent. Solution to this was Eve Login. And Eve Login evaluates each user login event on the web or mobile platform, and we provide approval, challenge, or denial, leveraging big data and advanced ML. So now you know about the use cases, you know about what the team does. Why are we here? Why did we leverage AWS Advanced Technologies? Well, let me tell you. So first, what we're very proud of, SIA successfully migrated most of their core services over to AWS in 2018. This was perfectly in line with the project timeline for Eve Purchase as we were going through this, and we said, you know what, why don't we let this be a born on the cloud initiative? We did this because this allowed us to leverage managed service resources so we could focus more on the business use cases than having to stand up infrastructure and use the classical style. This allowed us to see an opportunity to accelerate our timeline and deliver faster to market, delivering ahead of schedule. So now I'm going to pass this over to Nick, and he's going to talk a little bit more about AWS Managed Service benefits.
Great, thank you for that. So we're going to go in a bit of a deeper dive here on the different AWS services and the managed service offerings that enable Sony to build the Eve platform. And then later on, I'll be handing it back off so that we can actually see that in action, so that we can break down the building blocks one at a time. First, when we're talking about the AWS managed services, we need to understand the benefits that they were designed in a purpose-built fashion to solve, and how that relates to Sony's use case here. The first component is scalability. So when we're thinking about an application and the underlying services that power it, we need that to be able to scale up or down dependent on demand, or let's say utilization when it comes to compute, or storage when it comes to our databases, and so on. When we're thinking about scalability and true scalability, we don't want to have to think about the underlying arbitrary distinctions and building blocks with respect to amount of storage space on a given database instance, because what this means is that the folks over here at Sony and the customers are going to have to continuously retune and retweak their applications to fit and optimally operate on that underlying infrastructure. When we think about this in a horizontally scalable fashion, instead what we do is we flip the script a bit. We want our services to be able to, or our applications to run in a lean way that is efficient from a unit economics of the given operation, and then we can essentially, using AWS managed services, scale out to as large of a size that we need at any given moment. And this makes the operations of scaling out a lot easier, and it means that you're often paying much more directly for the value you're receiving. Next, we want this to be able to be maintainable. So when we are thinking about how customers can deliver value to their end users, we understand that there's a lot of operations that we like to call undifferentiated heavy lifting. What this means is it's some sort of work or labor that your engineers need to do in order to keep your application live, secure, performant, scalable. Oftentimes, these are things that are not unique to your business problem. And so with the AWS managed services, you abstract this away for us to be able to worry about, so that we can be really good at running data centers and helping to scale your application. And you can worry about writing the application that delivers joy to your customers. Further, while a lot of these underlying parts of your stack may be abstracted away, it's really important that we still surface the underlying metrics and performance values like CPU utilization, or amount that you're currently storing in your database, or the throughput that you have through a given part of your stack. This is all made available through things like CloudWatch alarms and metrics, so that even though you have that abstracted away, you can still conditionally monitor or have alarms set based on these behaviors or underlying properties. So you kind of get the best of both worlds. It's managed away from you, but you still have insight into how it's performing, so that you can understand how it works and adjust accordingly. Now, one step deeper beyond the layer of having a managed service, we have serverless architecture principles and core values. This is, again, some sort of a level of subsidiary underneath the fact that it's a managed service. So the first core principle here that I can't stress enough is the fact that there is no underlying infrastructure provisioning or management. And to a lot of folks who are new to the serverless world, this can often come as a shock. Ultimately, what we want you to do is not think about how many instances of your certain compute load are running on a given piece of middleman infrastructure, like how many workers are running on a given EC2 instance, right? In theory, all you should need to know is how many events do I have, which correlates to a certain number of workers, and that should be it. We'll see that this parallel draws extending beyond compute and goes to the database world, the data ingestion, and ultimately ETL as well. It's extremely powerful. Next, we want you to pay for value. In the process of removing that middleman architecture, or that middleman sort of infrastructure, what this means is instead of enabling you to rent space on a rack somewhere for a virtual server, or renting a certain instance that houses a database that's hosted on it, instead we want you to pay for value, not clock time that you then have to figure out and worry about optimizing and using. What this means is that in an instance for an event-driven compute scenario, when an event happens, spin up a function, execute that code, and then tear it down. And you only get charged for the execution of that individual function. This again extends to databases and storage and lots of other given scenarios. But again, we're moving away from this renting time on a wall, and instead you paying directly for value that your end users are hopefully receiving. Next, the ability to have this automatically scale due to the fact that we're breaking it down to more primitive building blocks is extremely tantamount. Again, when we think about unit economics, we think about things like in terms of, I have one table, I shouldn't need to think about how many instances I shard my tables across, right? You should have a table, and if in a serverless world, it should scale out. You shouldn't have to manage things like connection pooling. Next, what this all allows us to do is to have consistent small building blocks that we can more easily string together, and this is valuable for a few reasons. First is going to be feature velocity. If you narrow the scope of each individual function within your organization or within your application, it becomes much easier to start iteratively and modularly adding new components to this system. And what that further enables is that you actually reduce the scope and the complexity and essentially the blast radius of your application. Now, instead of having a monolith that you need to perform operation on anytime something's not behaving as you expect, instead you have this modular component system that allows out of the box with things like CloudWatch metrics, the insight and observability to enable you to actually understand what's going on. And if something does break, it again completely reduces the blast radius of that given error. Okay, so we've talked about managed services, talked a little bit about serverless. Let's get into the individual classes of applications and AWS services and what those enable. So first we have data storage. There's lots of different ways and manners in which you will store your data, but S3 is an extremely common one. S3 is a highly durable object store, so imagine files of any size. And it has 11 nines of durability. That means your data, if you put it into S3, is extremely likely to not be corrupted or disappear at any point in the near future. Again, 11 nines of durability. This enables you to put or access your data anywhere, and there are lots of cross-region functionalities like replication that are extremely valuable if you have data sets that need to be available on a global scale. With a company like Sony, this is extremely valuable, right? Let's say you have your PlayStation Network account in the United States, and then maybe you go to another region. You shouldn't be completely forbidden from logging in just because the data on the technical side wasn't able to be available there, right? Something like S3 enables you to use one tool and then have that very easily populated on a global scale. Next, we have DynamoDB. This is going to be one of the key data stores of choice with respect to databases here. It is a key value NoSQL database with single-digit millisecond queries for some of the most popular ones. And I think the most important point here with respect to DynamoDB, it is a managed service that is completely serverless, and you don't manage any of your connection pooling, and it has automatic scaling. And what I mean by automatic scaling is that you don't actually have to think about, what is my current, at any one point in time, number of instances that DynamoDB is being powered by? What is my read throughput? What is my write throughput? How do I scale each of those? You don't worry about any of that. It has extremely high throughput, and if you don't believe me when I just say that, believe me when I say that we actually at Amazon Retail use DynamoDB extensively. We use it to power Prime Day. And over 48 hours, DynamoDB's public API, the same one that all of you as customers vend, served 7.1 trillion requests over 48 hours from our Amazon retail side at a peak throughput of around 45 million requests per second. Again, that was without a hiccup on our side internally, but also for customers. We're using the publicly available option there. It still did not cause a hiccup for any of our customers. So when I say scale, when it comes to DynamoDB, I really mean it. Okay, next up, we have our data stored. While we have compute, we need to perform some pre-processing on our data, or we need to be able to move it around from one place to another, right? So the first service we want to talk about here is AWS Lambda. When we think about wanting to run code and execute code in a runtime in a serverless fashion without worrying about any of the underlying infrastructure, Lambda is exactly that. You write code in what can be a 15-minute maximum runtime or maximum runtime, 3 gigabytes of RAM, and it essentially, upon event trigger, will spin up the Lambda, it will execute its code, and it will tear itself down. Unlimited concurrency, no need to manage the underlying scaling, and again, in the AWS ecosystem, we have really natural synergies with respect to these event triggers and then it auto-scaling down. So for example, I just mentioned S3. This is an object storage. You can have a pipeline such that when an object or a new file is uploaded to S3, that then triggers a Lambda to perform processing on that object. And with event triggers in AWS, and in Lambda specifically, it actually inherits the context of said event. So if I upload a new image or a new transaction history, I can then have my Lambda automatically perform some sort of processing on said upload and execute my code and spin itself down. You as the customer only get charged for the clock cycles of that individual Lambda times the number of Lambdas that you have running totally and cumulatively at the end of the month. Runtimes for all languages, we released custom runtimes and bring your own runtime if you run some sort of very unique or rare sort of runtime or you want to build your own layers and packages. Next, we have Glue. So this is a more purpose-built solution for ETL. So we can run any sort of compute we want with Lambda, but there are some timeouts, some size constraints around memory. With Glue, what this enables us to do is perform ETL, so extract, transform, and loading of our data. what you do with Glue is you point it at a certain origin of your data. You point it at a destination that you want. Maybe this is from S3 to Redshift or a database to S3, what have you. And what you can do is you can essentially write, similar to Lambda, code that will perform an operation on your data, and you don't have to manage the underlying infrastructure. You don't have to spin up infrastructure that you deploy a Glue job to. You just run your Glue job. You don't have to worry about how big your data is because AWS manages that under the hood. Again, you're only going to then pay for the compute that you're using through ETL, through Glue, and it has really awesome ETL-specific functionalities like automatic schema detection, which when you open it up in the console enables you to see really easy things like if I want to change a string to a date time, you can actually do that just with a few clicks and then run your job. It's really easy and very handy. Next, we have data transport. I know some of this may have a little bit of overlap with ETL, but data transport is its own beast unto itself. So first we have Amazon Kinesis Data Firehose. I know it's a mouthful. But essentially what we have here is we have one or many streams of events. We mentioned before that for Eve, it needs to work with both mobile and console and web as well. And so you have these different streams that data is coming in at some unknown rate. And the point here is especially when you want to run something in real time, you can't sample and assume that data is going to be there on some sort of set interval. You need to process those events as they come in. And setting a data stream to that origin is critical to this. Once we have that data stream set up, we can actually ingest that data using Kinesis Data Firehose, and this will enable you to continuously load that data as it comes in real time from the stream to your destination of choice. DynamoDB or S3, as we mentioned before, are really common examples. And as that data comes in, you're probably connecting the dots, but that can then be an event trigger for Lambda to then perform some sort of processing. And you have the ability to batch, transform, encrypt, and a lot of other things. But one that is really interesting is actually the ability to use Kinesis data analytics. And what this enables you to do is actually push some of the common aggregations or transformations or analytics further up the stream. So much like I said, we want to cut out a lot of these intermediate sort of storage and compute layers that are often common in applications. With data analytics, you can do things like preferential routing based on conditions in your data, or perform really basic transformations in your data that not only cut out another part of your pipeline that can otherwise be excessive, but again, just reduces the blast radius of any sort of components in your system. And it does it all in real time. Imagine it as this little gauge right at the end of your fire hose nozzle that can then process this data as it's coming in. Okay, so these are all of the primitives that make everything work, right? But when we have our application deployed, there's a little bit more to it than that, right? We want to have rapid deployments. We want to be able to have insight and observability into our application. And when it comes to observability, CloudWatch is exactly the tool for the job. I spoke before about how even though you use an AWS managed service and some of that is abstracted away, you still have insight into how your application is behaving under the hood. And this can be really important for understanding and recognizing events in real time as they're happening. CloudWatch enables you to set monitors and alarms on these given metrics, like number of concurrent lambdas that you may have at one time, number of reads and writes on, let's say, a DynamoDB instance. And you can set this up and view those all in real time through the dashboard, or again, set the monitoring and the alarms to what you want. So if you have someone on call and you have a threshold for alerting them, that could be something that you want. And again, you can set your own custom metrics. If you understand your stack, you understand what those thresholds are. You know your application and your users' behavior better than we do, and we want to give you the tools to empower you to do that. And then lastly, you have observability into any version of your stack, but we want you to be able to deploy your stack in a reproducible and sort of, basically a reproducible way, yeah. And AWS CloudFormation is going to enable you to do that. So you might have heard infrastructure as code, IAC as an acronym in the past. Essentially, this enables you to define a configuration file in either YAML or JSON, and this is going to essentially be a proverbial diagram of your entire application stack that will enable you to redeploy this either in another region or make slight changes to this instead of having to manually go through your console or using the AWS CLI to be able to do this going forward. Essentially, your deployment can be one atomic action where you deploy your stack entirely at one time, and if certain components fail, you can have logic around that such that if it fails, the entire stack fails, so that you don't have some sort of false positive around the deployment of your stack. We've heard from customers that writing CloudFormation code and configuration can be very wordy, and we've since released in the past year the AWS CDK, Cloud Development Kit, which is actually a native SDK that you can write in Python or JavaScript, and I believe recently Java, that enables you to actually declaratively write code that will then compile to CloudFormation templates. So when we think about tying this all together, yes, we have a lot of primitives, but there are a few core value propositions that are consistent throughout. And this is one of the most important ones. Everything from ingestion to storage can be done in a serverless fashion. Further, any single time you have a pipeline, it makes me think of two things. First, if you have a pipeline, your pipeline does not deliver business value to you or to your users unless it works from end to end. If there's any single part of that pipeline that doesn't work, doesn't matter. It doesn't matter how performant one part of your application is. If another part is down, it won't work. Second, you're only as strong as your weakest link. So you can go serverless or you can go managed services for some parts of your pipeline, but ultimately your bottleneck is going to be whatever the lowest amount of bandwidth or throughput is throughout your entire application stack. With AWS services and the managed service and the serverless ones we've spoken about today, you'll see at the end of this talk how each of them, there's no bottleneck essentially in sight when it comes to thinking about the ability to scale out and have availability and durability of our data. By separating all of these different tasks and functionalities of our application in the Eve system amongst all of these different purpose-built tools, it enables us to basically pair the right tool for the right job. And this is really one of the most important things when it comes to developing and using AWS services in production. The biggest take-home values of when you properly pair a workload to a tool is that you're going to reduce the cost, you're going to be able to launch features more quickly, and you're going to be able to optimize in the world that you live in the world where you design features for your users and don't have to worry about the underlying messy things like running a data center and running these managed services. We like to take that on, but without further ado, I'd like to pass it on to Sony to talk a little bit more about what this system looks like in real time.
Thanks, Nick. Hi, everyone. So Eric mentioned how the system we were trying to build, and Nick introduced some AWS managed services to you. Now I'm going to tell you how we put this all together to build a system for real-time data analytics. All right, machine learning. I have everyone's attention now? Sorry, now that I have your attention, I'm not going to be talking much about machine learning today, I apologize. We do use machine learning, don't get me wrong, but machine learning is only as good as the data you provide your models. So if you have a machine learning model with only one parameter, it's not going to be able to make a very informed decision. And that's what I want to talk about today is the type of data and data analytics that we provided in our system to make really informed decisions. So the data we landed on is this concept of an aggregation. So we wanted to aggregate data on our platform over time. This is the most powerful indicator for risk because it's based on contextual data on our platform. So our real-time data analytics system provides a set of aggregated data for our events on our platform. Some examples of this, so how many different IP addresses have I seen for an account in the last 7 days? Or how many times has a device tried to buy something in the last hour? So the system we built on AWS provides these types of data analytics to our machine learning models in real time. So before I go into the actual system, I wanted to level set with where our heads were at coming into this, building this system. So our key system requirements, right? First of all, speed, right? I want my bunny suit and I want it now. I joke about this, but customer interaction for us is very important. We take it very seriously. We want to reduce friction as much as possible for our good customers. Scale, very important. So Eric talked about this elusive use case N that we chase. So we wanted to be able to build this system for any event on our platform. And SIE has unique traffic patterns when certain games release certain events that really drive traffic in a unique way to our platform. We want to be able to handle that. And last but not least, resilience, fault tolerance. So we wanted to be able to be fault tolerant from both a machine perspective and a human perspective. They wanted to let me write code. And as my QA engineer, Adrian, tells me, I do tend to write the occasional bug. So we want to make sure that we're protected from that as well. So where did we land on? We landed on an architecture called the Lambda architecture. Not to be confused with AWS Lambda. We'll get there, I promise. But the Lambda architecture is a best practice for data processing. And what it does is it combines batch processing to create accurate and consistent views of your data, while also providing a streaming portion to provide data more quickly to your system. So this is a very, very high-level view of a Lambda architecture. You can see data streaming into multiple different layers in the system, both a batch and a speed layer. So the batch layer, the entry point is this concept of a master data set. And this is a mutable append-only log of the raw events we've seen on our platform. Those are then computed into batch views, but that takes time. So while that's happening, we supplement that with real-time stream processing into real-time views. And then you can combine those two views together to provide that higher level analytics question and the answer to that question. So why did we land on the Lambda architecture? So first is complexity isolation. incremental updates to data is very complex. So we push that complexity into a layer that is temporal. So once the data persists into the batch views, we actually no longer need the data that is provided by the real-time stream processing. And with that, we actually get eventual accuracy. So while the speed layer's focus is on availability of the data, if there is ever a problem in those incremental computations, we're able to supplement that data with our batch views once they're computed, and we disregard the data from our speed layers. And fault tolerance, right? So Tom gets his hands on the code. So that master data set is really important. If we ever make a mistake in our batch computations, we're able to go back to our master data set and recompute all of our views and store them into the batch view. And if there's a problem in the speed layer, those results are temporary anyways, so they'll go away once we've reverted the problem. So what does this actually look like? Let's put it all together. I know this is a very busy slide, but this is an Eve system running on AWS. There's machine learning there. I told you we used it. It's there. But most importantly, I think is the entry point to our system is a microservice, a REST API. I want to screen an event for risk. That is an orchestration layer. It is gathering the data, interacting with the machine learning models, and providing the decision back up to the calling system. So it reaches out to another microservice running on another set of EC2s, and that is responsible for querying the data across both of our batch views and our speed views and providing that aggregated data back up to the orchestration layer. So once that's all done, the orchestration has got the aggregations, went to the models, got a decision, and provided it upstream. We actually persist that current event into a Kinesis data stream, into our aggregation framework, so that it can be part of aggregations for subsequent events. And so we're going to go in the next couple of slides, a journey into that event and how it works in both the batch and speed layer on AWS services. So let's start with the batch layer. So the first part of the batch layer is a Kinesis data firehose. That is one of our consumers of our Kinesis data stream. And this is really just responsible for delivering the data into our master data set. But it does provide one key piece of functionality for us. We're able to convert our raw JSON data into a Parquet format, so it's optimized for our ETL processing. Amazon S3 is our master data set. As Nick mentioned, it's got a lot of nines, so that was really important to us in terms of durability. So once the data is persisted into S3, in comes Glue. So Glue is our ETL framework. We run hourly and daily Glue Spark jobs that are responsible for providing these calculations on top of the raw data and persisting that data into our batch view. Our batch view is a DynamoDB table, but the operations on this DynamoDB table is batch insert operations. All the calculations are done at once in our ETL processing framework and persisted in a single item at one time. So that takes time, right? So the batch Glue jobs are running hourly and daily, so we need to supplement the data in the meantime, and that's where our speed layer comes into play. So another consumer of our Kinesis data stream is a Kinesis data analytics application. It's running custom SQL every 1 second and firing aggregated data to an output source. That output source is an AWS Lambda. Here's the Lambda within the Lambda architecture. And so the Lambda's responsibility is really for organizing the data to optimize it for writes to the database. And then because we want to scale as the data patterns increase, we actually fan out the writes to our database to another set of Lambdas that run concurrently so we can get better throughput as more data comes into our system. That Lambda is responsible for writing to another DynamoDB table, which is our speed view. And that speed view, the operations performed on that are incremental updates. So this data is streaming in and we're performing incremental updates on the items in this table. So that's a brief overview of the Lambda architecture and how we built it on AWS Managed Services. I want to deep dive into a couple key areas of the system that I think were important as we built this system. So the first one is optimizing for read. One of the first requirements we had was speed. So the customer is waiting. Pulling the data out of our Dynamo tables is one of the most important things for us. So how did we create our data model in a way that made that fast? So as data events come into our system, they occur in real time. And what we're doing is we're creating intervals of data from the raw events. So we're organizing the data into day, hour, and minute intervals and storing them into DynamoDB items. So what does that look like? So as Nick mentioned, NoSQL, right? Key value store. Our key is actually the item that we're aggregating data against, along with the interval that we're storing for that data. And then the sort key of our Dynamo table is the actual number representation of the time bucket that item represents. So some examples here, that account for that hour, all of the aggregated data is stored in one Dynamo item for that account in that item. Similarly for the IP address, every aggregated data piece for that IP in that minute is stored in one Dynamo item. So why is that fast? So I want to walk you through an example of why that matters and why that's important. So let's break down a simple aggregation. How many times this account attempted to buy something in the last 30 days? So what we do is we go after our minute time intervals, both today and 30 days ago. And for our minutes, we're actually going to our speed views and our batch views. And if data exists in our batch views, we can discard the data that we've retrieved from our speed layer. We get hours, both 30 days ago and today, and days in between. So we run all of these queries in parallel for optimizations and speed as well. And every single query is capped at the total number of possible items it might need to retrieve. So at most, we're retrieving 60 minutes, 23 hours, and 29 days. And this scales for any type of aggregation time length that we want to calculate. We can do month buckets for year intervals. We can do 5-year aggregations and have year Dynamo items and consistently cap the number of items we need to pull from our database. And we've seen really good performance out of this data model. So now that we're fast in real time, we also wanted to be fast in developing and deploying the system to other events on our platform. So again, back to this use case N idea, extensibility was really important when we came to build this system. So what we did is instead of trying to build to aggregations, we built to the concept of an aggregation. So again, we have another example here of what an aggregation is. You can break down every single aggregation into a repeatable structure. So it's an operation on a key and a value for an event over some time period. So once you have this concept, you can write your software to this model and not have to know about the underlying aggregations that you're actually building and providing to the system. So what does this look like? So our services all pull configuration, and they have no knowledge of the actual aggregations that they're running. So we store all of our aggregations in a configuration store, and as I mentioned, we have a microservice that's responsible for interacting with our DynamoDB tables. It pulls at runtime the aggregations that it needs to process from this configuration store and translates that into queries. Our glue jobs pull that same configuration to understand what columns to pull from S3 and what items to write into our batch views. And while for Kinesis Analytics, while you can't pull configuration at runtime because it's just running SQL, we were able to run our configuration through a templating engine to generate the SQL so that we're all working off the same source of truth for the aggregations that are required for an event. And this has been really cool for us for a number of reasons. We can add and remove aggregations for any event with no code changes. We can onboard new events with no new software. And when we do add features to our aggregation framework, it actually is available for any event on our platform. All right, more buzzwords, big data, right? So I joke, but the PlayStation Network does see millions of transactions a day. And one of the aggregations that we wanted to provide is this idea of number of unique items I've seen over a time period. And for that, you have to store sets. And for these large time intervals, these set sizes can grow to a massive size and actually exceed the limits of DynamoDB. So a DynamoDB item, the max limit you can have for an item is 400 kilobytes. And that's not that much considering if you have 5,000 unique items in a set. So what we decided to do is introduce an approximation algorithm called hyperlog+. It's an open source algorithm, and that allows us to represent unique items in a set in a data structure using a hashing algorithm. And so we see really good performance and really good accuracy for really low set sizes. So for small sets, hyperlog+ is 100% accurate. And as you grow to really large sets, you still maintain that level of accuracy that we need for risk analysis, but maintaining a size limitation that is acceptable for us to provide the feature. So you can see here, a very large set can get only up to about 20 kilobytes. And that has a lot of really good things for us. So we can get less writing, less reading, so our capacity is lower and our cost is lower. And also, at query time, we're pulling less data out of our database, so the actual performance of the querying is faster. So that's some of the highlights that I wanted to cover. I'm going to pass it back to Eric now, and he's going to talk about whether it worked or not.
Great, thanks a lot, Tom. So as I said, we went through our story. Nick and Tom were able to do a good job talking to us about the managed services and how we were able to leverage them. Thank you. And I'm going to go through what I love is what actually happened at the end. Were we successful? So use case 1, purchase. It was an overwhelming success. And we're going to dive a little bit deep into that. So first of all, what we're able to do is increase our approval rate by a shocking whopping 3%. Now you're going to say, okay, big deal, 3%, whatever. Well, times it by millions of transactions a day over the whole world, it's a pretty big deal, and it was a pretty big success. As stated, our goal was to increase approval rate and keeping chargeback rate flat. We were able to successfully do that. We were also able to reduce our latency from the current provider which we had, which took about 2 seconds to assess fraud and risk, down to under 200 milliseconds, which is a pretty amazing feat. We were also able to improve our risk decline and accuracy. What this means is we reduce false positives, allowing more good customers to buy the things that they wanted when they wanted to buy it, which is creating that world-class experience. So to dive a little bit deeper into our results, Eve Purchase went live in the middle of January 2019 and had some pretty noticeable results. So we're going to look at some charts, a little bit busy. I got a couple points I'm going to highlight. So first, what we did, you'll notice December 2018, we loosened all the rules a little bit for holiday traffic because we wanted to let more people through. What you're going to notice what we did right here as well is we have Eve Purchase running shadow in the background so we could understand how the system was working because we never just released something right at time without looking to see how it's going to perform. Then you'll see we released Eve Purchase mid-Jan 2019, and you'll notice from then we had a noticeable increase, around 2.5%, up to around 3%. Then as the year went on, we introduced additional features, we tuned the system, we were able to keep it at least at the same, if not a little bit better, than when we initially released it. Now let's take a look at the risk decline and accuracy chart. This again is reducing false positives. We installed Eve Purchase mid-Jan, and you notice from then we had a significant decline in false positives, again allowing more good people to buy the things that they want. And then throughout the year, we were able to further reduce it and provide that overwhelmingly world-class experience. Second use case is Eve Login, or what we also call risk-based authentication. We released it in August of this year, and so far, we're definitely bringing the fight. We have been able to proactively warn customers of suspicious activity through email, which was our first release. And out of the warning emails, we got about a 20% response rate. And if anybody knows by doing email campaigns, that's pretty good response. Most people don't look at their emails at all. And what we mean is they actually went in and changed their passwords to prevent their accounts from actually being taken over. Out of that, potentially about 15,000 customers have been proactively warned and have possibly stopped an account takeover since August. So since this release, these slides were put together around September, we've done our second release. And what this does is actually provide a challenge. Now, it's important to note that PlayStation Network has always provided two-step verification, but before this, it was an opt-in process. Now, it is no longer opt-in. We will proactively do two-step verification if we identify any fraudulent or risky behavior to protect you on the platform. So now we heard about the great results. Let's talk about what we could have done better. And for that, I'm going to hand it back to Tom to talk to you about what he did.
Thanks. Yeah, the boss gets to talk about all the good stuff, and I get the mic handed back for all the bad stuff.
It's a management thing.
All right, so these are only a few lessons learned, but I thought we'd highlight a couple things as new customers coming into the AWS space for stuff we had to adapt to along the way. So the very first one is the thing that Nick mentioned about paying for value. The thing is that AWS will let you pay if you want to, right? As much value as you want to get out of these serverless applications, you'll pay for it. So we struggle with this idea of how accurate does our risk assessment and aggregations need to be, and how small should our bucket sizes be for the items that we're storing in DynamoDB. We could have went with smaller granularity, but that would have exploded the number of items that we had to store and explode our costs. And so working with our business counterparts, we were able to come up with a cost-effective solution that still maintained the level of accuracy that we required to do the risk assessments on our platform. The second was this idea of infrastructure as code. It's great. We wanted repeatable infrastructure. We wanted to deploy infrastructure consistently. But what we found is that AWS CloudFormation tends to not support all of the things you need to be completely hands-off for deploying your infrastructure. So things like when you actually deploy a Kinesis Data Analytics application, it's not actually running. So you have to deploy something to make it run. And so what we did is we built custom Lambdas into our deployment pipelines, but we had to build that development into our project plan to be able to support that.
Actually, to jump in there, and again, this was in September. Just a few weeks ago, we released custom resources for AWS CloudFormation. So not only can you actually build your own custom resources for AWS services that we don't have official first-party support for, but you can actually define your own custom resources, in a completely custom manner. So you wrote Lambdas to do that, but going forward now, you can keep your entire stack directly within CloudFormation.
That's
so
great, yeah.
Exciting stuff, even during this week, launching more things.
And that's why we're here too. We love to hear all the cool stuff that is going to make our lives easier. So maybe that won't be a lesson learned for new people coming into this. And security, obviously very important. This is something we bake in from the very beginning. This is sensitive platform data, but we really scrutinize over making sure everything is encrypted, both in transit and in rest. And our identity access management policies scrutinized over to make sure we're providing the least access possible so that only the things that needed to see this data see this data. Like I said, there's plenty more lessons learned. Happy to talk further in person if anybody wants to go in depth more about what some of the other challenges that we faced. So what's next for us? So we've got more things coming. We're continuing our chase of this elusive use case N. So we're going to be installing this Eve system across more and more events on our platform. And that will give us this holistic 360-degree view of risk across our platform as well. And we're here at reInvent. We're exploring all the new technologies and probably blowing up our sprint planning once we hear all the new announcements that come up this week. It gives Eric a couple more gray hairs, but it's
Can't
really
wait
exciting.
to tell the business and product. They're just going to love you for that one.
We should really plan for reInvent in our sprint planning, to be honest. And we're growing our teams. So we have a great team right now, don't get me wrong. We built a really cool system, but as we grow and want to add more and more functionality, we're growing our teams in both the Bay Area and Southern California. So really thankful for everyone to sit and learn about our story here, and I think we're going to open it up for questions now.
Yeah, so thank you for that. We'll hold applause till the end, but we actually have a few minutes, about 10 minutes for Q&A. If you're interested in asking questions, we have 2 stand-up mics in the aisles. Please line up in an orderly fashion. If you have questions that you want to ask directly or more privately, we'll actually be hanging out in the hall directly after this talk. So yeah, feel free. We've got one question over there on the left.